put this scene together to demonstrate linking various data sources into a single unified scene. Whilst the initial test models were untextured and simple shapes, I used the blue marble imagery from NASA to create a textured globe, a few simple GL shaders for the atmosphere and sun. However, the key component was the data source, which came from the OpenSky network. The OpenSky network provides a REST API connection to live flight data. Using a simple lat-long range query to return flight details in JSON, data was parsed into a table. My math skills, propped up by Google, a colleague, and a cinematic maths overlay sequence, I could position my planes in the scene and update their position and heading every 10 seconds. For recording a spline trail, the flight path could be seen behind the aircraft. Using node observers, I could retrieve the flight details from the table and populate my flight information GUI when selecting an aircraft in the 3D scene. With each aircraft having a unique ICAO number, I could then use that to query airportdata.com, use their API to see if there was an image of the selected plane available. If one matched, the aircraft image would be added to my GUI, and with those not found, showing plane 404. Initial selection was based on drawing a rectangle on the globe that was then converted from a 3D space to a lat-long range to create the query. The next step was to add the airports to allow selection. Having located a CSV file of the approximate 9,000 airports around the world, I used a CSV parser to read in the data source and store relevant metadata with each airport. Whilst my query could be adapted to the arrivals, departures to the selected airport, I decided to just block an area of airspace around the selected airport. The final step was to try and identify aircraft types, so that not every aircraft model is a 737. The OpenFlight site also contains an airframe database available to download as CSV, and whilst not a complete record, it contains a large amount of information on airframes. Splitting the generic aircraft into types was done using a type code. L1J for a single-engine jet. Using several online open-source CAD models and previous models I've built, I compared the ICAO number from a flight query to the airframe CSV to change the model to a more accurate representation. Whilst there's nothing groundbreaking within the demo, it highlights how even a non-programmer like myself, with a bit of knowledge, can bring together multiple data sources into a single scene to provide a clear, data-rich model.